So we talked in my previous video about what surface area is and how we get the formula for cylinders and prisms, rectangular prisms or triangular prisms, any type of prism. Today we're going to talk about how to use that formula and actually find the surface area, and we're going to include the surface area of a sphere as well. So the surface area, SA, is the area of all the surfaces combined, so the top, the bottom, left, right, front, and back for the rectangular prism. And we want to be familiar with what each letter in the formula means. The B doesn't mean base, it means area of the base. So we think of which shape is the base. In this case it would be a rectangle, and in the cylinder the base would be a circle. So the area of the base, we don't want to forget that a circle's area is pi r squared. And we can see that formula is actually being used in a sphere, 4 pi r squared. We also want to remember that the area of a rectangle is length times width, a triangle is half base times height, so we need to be familiar with the basic formulas for shapes for area. The second letter is a capital P, and this is referring to the perimeter of the base shape. And whenever we have a prism, there's going to be a base shape. In this case, it's a rectangle. We could have a triangular prism, in which case the base is a triangle. So it's the perimeter of that base shape. So I would get the perimeter of this, the perimeter of the rectangle. And one thing we want to remember is that the perimeter of a circle is known as its circumference. So if we can remember that, then we know the circumference formula we're going to use is, in a circle, the circumference or the perimeter is 2 pi r, or is the way we plug it in is 2r pi. So we're going to see how, if we can be familiar with the circle formula for area and for circumference, as well as the area formulas for the basic shapes, we can find the surface areas of prisms and cylinders. We're going to take a quick look at spheres. Spheres have an easy formula. 4 times the area. Really, it's 4 times the area of the base shape or the starting 2D shape. We saw that if you take a circle or a quarter and spin it, it would make a sphere. So it's the area of one of those circles, and it's interesting, it's one of those areas times 4. So that's saying that if we get 4 circles exactly the same size as this sphere, and we cut them out of paper, 4 of those circles cut out in paper would fit perfectly without any leftover around the sphere. So if we think of it as a basketball, we can get the diameter of the basketball and cut out a circle with the same diameter, and 4 of those circles would be the leather we use to cover up the basketball. So let's take a look at some practice problems for solving some prisms and cylinders, and at the end we'll do spheres. So if we have a rectangular prism, what I try to recommend my students do is, first locate the area of the base and ask yourself, what is the base's shape? And in this case, we can use different possibilities for the bases, but I'll use the bottom, and I'll draw that by itself. So we need some numbers here. Let's make it a 4 by 4 for the base, so it's a square, and we'll make the height 12. So if I take that base shape and put in the numbers 4 and 4, we're going to find the 2 things we need for our formula. Our surface area is 2 times the area of the base plus the perimeter of the base times the height. So we're using this base shape right here to get the capital B and the capital P. The capital B means the area of that shape, and we know the area of a square or rectangle is length times width, so 4 times 4, which is 16. We can also get the perimeter of that shape, and if we remember, perimeter is adding up all the edges. We'd start here, there's 4, another 4, another 4, another 4. I like to fill in the numbers just to be just a little bit more focused. So the perimeter is the 4 plus 4 plus 4 plus 4, or 16, coincidentally, the same number. That will not always happen. So we're going to finish by plugging this in with the height. The height is how far is the top base from the bottom base, and the height of that is 12. So again, our perimeter we got by adding all the sides, 4 plus 4 plus 4 plus 4 of the base, and our area was multiplying 4 times 4. So our surface area is 2 times the capital B, the area of the base, which is 16, plus the perimeter of the base, also 16, times the height, 32, plus, I believe, 192, and we would add that, and we'd get 124. I'm sorry, 224. I believe. Trying to do it in my head. Let's double check and get out the calculator. Times 12 is 192 plus 32, and it is 224. And of course, if we have a unit of measurement like meters, okay, the first one's 4 times 4 meters, it's 16 meters squared, and the perimeter is going to be just meters, and the height is meters. So when we end up multiplying, this surface area, or anything with area, is going to have units squared or meters squared. So this will work in other shapes, even a triangular prism. In a triangular prism, you think of how it's formed by stacking triangular bases. So our height is how far the front triangle and the rear triangle are. And let's use 6, 8, and 10 for the triangle's dimensions. So we're going to take that base shape, which again I recommend you just cut it out here and use it by itself to stay focused. And we want to get the area of the base, which is capital B. So the area of a triangle is half the base times the height. And our base and height must always make a right angle. They must always be perpendicular. So we're going to use the 6 and the 8. So the area is 1/2 6 times 8, which is 24. Then we're going to get the perimeter. So the perimeter, or the P, in our formula, remember the formula is 2 area of the bases plus the perimeter of the base times height. The perimeter is to add up all the edges, 10 plus 8 plus 6, 14, 24. Our height is how far apart the front and rear base, the two triangles are, or how many layers of triangles we have is 12. And we simply put it together. Surface area is 2 times the area of the base plus the perimeter of the base times the height. So here we have 48. Let's pull the calculator up for this one. 2 times 24. Oops. 24 times 12, not 2. It's 288 plus 48. Was it 336? I already forgot. 336. So again, we find the base shape's area, that's the capital B. We find the perimeter of the base shape. And the height is how far the two base shapes are from each other. So the next shape is a circle, or it's not a circle, a cylinder, which has a base of a circle. So let's make the radius 10 and the height of it 30. If I take this base here and draw it here, I know the radius is 10. If my formula is 2 times the area of the base plus the perimeter times the height, we want to just remember the idea or concept that a perimeter of a circle is called the circumference. But rather than have multiple formulas, if we can just remember this, we don't need a separate formula for cylinders. So the circumference of a circle is 2r pi or 2 pi r. I put the r in front since we plug in a number there. It puts them next to each other. The capital B is the area of the circle. So we want to remember the area is, again, pi r squared for a circle. So if I want to find the area of that shape, it's going to be pi r squared, or pi r squared pi, we could say, which is 100 pi. To find my perimeter or my circumference, it's 2 times the radius times pi, or 20 pi. And my height is how tall the cylinder is, or how far the top circle is from the bottom circle, is 30. And we simply are going to put those together in our formula. 2 times the area of the base, I almost forgot the pi, plus the circumference or perimeter of the base times the height. And so here we'll have 200 pi plus 600 pi, or 800 pi total surface area. And it would be units square. Surface area is an area, and so it would be measured in squares of whatever unit you are using. So again, we take the circle, find the area, capital B, find the perimeter or circumference, and plug it in with our height into our formula. So the other shape we said we would look at is a pretty simple formula. If we can find the area of one circle, we just multiply it by 4. Surface area, or how much area would cover a sphere or a ball, is 4 times the area of one of the circles with the same radius. So 4 pi r squared. If we make a radius with a 10 as a unit, let's say meters, 10 meter radius, we're just simply going to say 4 times pi times 10 squared. We plug the 10 in, or the radius in, for r. 10 times 10 is 100, so 4 times 100 times pi is 400 pi. So you simply plug in the radius, and it's not a lot of calculating or extra steps. So again, this will work even in other shapes. We could take, a hexagonal prism. If we know how to find the area and perimeter of the hexagon, we can do the exact same formula. 2 times the area of the base. In this case, the base would be the area of the hexagon, plus the perimeter. I'd have to add up all the sides of the hexagon times the height, or how many layers the hexagon's prism had. So surface area is, in these few shapes, is 2b plus ph, and in a sphere, the surface area is 4 pi r squared. If we're using a cylinder, we want to remember, we can write the formula down and memorize it, but if we don't want to memorize, we just want to remember it's 2 times the area, or 2 pi r squared, plus the perimeter or circumference, we call it 2r pi, times height. So, if you're allowed to use a card or you want to memorize it, this would be another way of writing the formula. The area of the base is pi r squared. The perimeter or circumference is 2r pi. So that is a nice little review of how we use the surface area formulas.